Hey guys, Fast here with another chemistry video. Today we will be doing gases Gallo 3, the ideal gas law. You could say that this equation is ideal for solving annoying gas problems. Get it? Ideal, like, ideal. Call a psychiatrist. Anyway, I'm going crazy. PV equals nRT. That's all the fussy fuss. That's what hip. That's what's up, dog. This is the thing ting ting tang. This is what it is. These 5 letters is the ideal gas law. And 5 letters means that there's 5 variables. P equals pressure in atmospheres. Um, by the way, precursor to this, you should have seen gases galore 1. And you don't have to see 2, but you should have seen gases galore 1 before this one. Gases galore 2, really, this doesn't relate with that. But gases galore 1, definitely you needed to see. Okay, anyway, P equals pressure in atmospheres, V equals volume, N equals total number of moles of gas, R equals the gas constant, which is 0.821 liters atm per moles Kelvin. Just focus on the 0.821. That's what you plug in, and it's a constant, so it's always going to be 0.821. It will never change for any problem. T equals temperature in kelvins. We went over how to convert this and how to convert this in gases galore 1. Okay, cool. That's really it. You just plug things in and solve. So here are the 4 steps. Make needed conversions, plug in the givens, substitute the desired for an x, and solve for x. 4 simple steps. Let's do an example. How many moles of oxygen must be placed in a 3-liter container in order to exert a pressure of 2 atmospheres at 25 degrees Celsius? Cool. Okay, step 1. Make the conversions. So in this case, we're given Celsius right here. And we need kelvins. So K equals Celsius plus 273. Kelvins equals 25 plus 273. Kelvins equals 298. Like I said, watch the first video if that didn't make sense. Alright, cool. Conversions, done. Step 2, plug in the givens. Let's see, what are we given? We're given volume, we are given pressure, we are given temperature, and we always know R. So PV equals nRT, we were given P and V, and we were given we were given T, and we always know R. So plug all those in, 2, 3, 0.0821, 298. N is what we're trying to find. So replace that with an X, and 2 times 3 equals 6, equals X times 0.0821 times 298 equals 24.47. So if you do a little rearranging of that, 6 equals 24.47x. That. Now you just solve for x by dividing. So 6 divided by 24.47 equals x. X equals 0.245. And thus, 0.245 moles of oxygen gas must be placed in the container. That's it. That's how you do it. Okay, one more example. A 4-liter container has 2 gases inside, neon and argon. It is known that at 18 degrees Celsius, the total pressure of the combined gases is 0.850 atmospheres. If it is known that there are 0.10 moles of neon in the container, how many moles of argon are in the container? Okay, step 1, make conversions. Always make conversions first. What do we need to convert here? We're given degrees Celsius. That's got to be Kelvin. Make it Kelvin, you get 291. And that's the only conversion we need. PV equals nRT. We are given the V, we're given volume, we are given temperature, we are given pressure, and we're given N. Now, we're kind of given N. Are we given N? That's my question to you. Are we? Because we're dealing with 2 gases, neon and argon. So, what? I mean, what? Is this N? Because this is 1.10 moles of neon. But what about argon? N equals total moles of gas, not moles of neon gas. So no, we aren't given N. That is what we're trying to find. Anyway, so we are given, though, volume, we are given temperature, we are given pressure, and we always know R. So PV equals nRT, PV, RT. We're trying to find n. So just like the last problem, substitute that with an x. 0.85 times 4 equals 3.4. 0.0821 times 291 equals 23.89. Solve for x. 3.4 over 23.89. X equals 0.142. So what is x? X is n, which is total moles of gas. Okay, total moles of gas. That is not what we're trying to find. We are trying to find how many moles of argon are in the container, given that there are 0.10 moles of neon. Well, if we know the total and we know the portion of it that is neon, can we find how much is argon? Yeah, we can. Like, if you have a basket of 10 apples and 3 of them are green, can you find how many apples are red? Yeah, you take the total minus the green and you get the red. That's the same concept here. We have the total. N is total, which means moles of argon gas plus moles of neon gas, because it's the total sum. And we know that total, because we just calculated it, is 0.142. And we know that the moles of argon, or of neon, is 0.10, because that's what the problem said. So now we just solve for moles of argon. So let me go back to the apples for a second. In our basket of red and green apples, we have 0.142 apples total. 0.10 of them are green. We're trying to find how many of them are red. So you subtract the number of green apples from total apples to find the number of red apples. In other words, 0.142 equals x plus 0.10. X equals 1.42 minus 0.10. X equals 0.040. And x equals 1.32. So what were we just finding again? Oh yeah, we're finding the moles of argon gas. So slap a label on that and you've got yourself an answer. 0.0, where did that come from? It's 1.32. 1.32 moles of argon gas are in the container. Boom, that's how you do it. Do not forget to answer what the problem is asking. For example, if you said the answer was 1.42, because that was the total moles, you'd be wrong. The problem wanted moles of argon gas, not total moles of gas. So keep that in mind. Remember what the problem is asking. I've made plenty of mistakes where I forget what the problem is asking and just write what I think it's asking, and it's wrong. I lose points for no reason. Cool, that's it for this video. If you liked this video, click that share button to share it. Yeah, the share button shares with anybody that you think might need help on this subject. If you have any questions, leave me a comment or check out my website, www.commercial. Yeah, that's all I got. See you next time.